And we're rolling. Let me
Okay, perfect. So,
pinned.
short recap. This presentation is about how to use open source CAD software to design electronic music instruments and hardware for media arts in general. And we are going to see how to build the instrument that we will see perform in a few seconds. So once again, don't judge if the audio quality is not good, as well as if I'm not a good
Okay,
musician,
I am
but
good. And okay, why don't you take it away, Nicolo, again,
yes,
please.
Okay, cool. So this was the video. And so let's see quickly how
Oops, now I can't hear you.
No?
Is that just me?
Yeah, I can hear Nicolo fine.
Okay, okay, cool, great. So should I keep going?
Yes, please.
Yeah, I'll keep going. Okay, okay. I'll keep.
Can you guys hear Nicolo?
Yes, it seems like yes, they can.
You can't. Okay, go.
Okay, so basically, let's see very quickly the structure of the instrument. It's basically made out of two plastic 3D printed shells, then a wooden handle that is made with a CNC milling machine, and of course a circuit that is basically a Arduino Uno shield. This is to make the hardware as accessible as possible, because I mean everybody knows Arduino now. One thing that I feel like sharing is that the workflow I will introduce is basically designed to be compatible with the Fab Lab and Makerspaces facilities. In other words, basically the technology we're going to see are basically accessible for a very wide range of people, because I mean, as you might know, the Fab Lab network is very diffused all over the world, including war zones and remote areas. So we can basically claim that anyone has access to the technologies that are needed to produce such an instrument. So the first thing to do, it's basically to design the circuit. To do this, I used KiCad, which is a very famous and performative tool to design electronic circuits. We can see in the right side of the screen the outcome of this process, which is a PCB. A PCB, maybe not everyone is familiar with how to produce them. There are basically two ways. The first one is that you can go you can commission them to a producer. Nowadays, the cost for producing PCBs decreased really a lot, so it's economically wise, it's very accessible as a technology to access. Otherwise, you can visit your local Fab Lab, and you can mill with a CNC milling machine the PCB on your own. Okay, so once we are done with the circuit, we move to Freecad. Freecad is a very performative parametric CAD software that basically allow us to generate three-dimensional volumes for several purposes. In our case, we can see at the top how the outcome of the procedure of Freecad, of the models made in Freecad, can be CNC milled with a CNC milling machine. And at the bottom, we can see basically the 3D printed shells after they've been 3D printed. Now, the cool thing of these first two slides is that these two softwares, KiCad and Freecad, can interact with each other thanks to an add-on that you can download for Freecad that is called KiCad Step Up. Basically, thanks to this plugin that we can implement in Freecad, we can basically import PCBs from KiCad, which is very useful because in this way you can basically 3D model a shell precisely around the circuit that you design, and vice versa. You can actually use the 2D design capabilities of Freecad, which are way more performative than the ones implemented on KiCad, and push back the outlines of the circuit. As you can see, the circuit of this device is like circular. To make this thing on Freecad would probably be, maybe for sure it was possible, but it would have probably been a pain in the ass, to say it in French. But in this way, thanks to the KiCad step-up add-on, you can do it using the very performative Freecad capabilities. So next step is to use Inkscape. I don't know if you guys are familiar with Inkscape, but Inkscape is a software, is a 2D vector graphic software, originally conceived for purely graphical purposes, such as, you know, posters, websites, whatever. But it is possible to export, actually, Freecad can import straight the SVG format that basically Inkscape uses natively. Why do we need this? For one simple reason. As I said before, Inkscape is very performative in terms of graphical properties. Here, for example, I used it to make a graphical pattern to place in the middle of the device to basically visualize where the gyroscope is placed, so that the user has a clearer view on where is the gyroscope. And yeah, basically the graphic I developed was a freak interpretation of Morse code. It's basically X and Y in Morse code. And to do that on Freecad, once again, could be possible, but with Inkscape goes way faster. Same thing goes for the electronics. Inkscape can export graphical patterns or whatever into PNG that can be implemented on KiCad, because on KiCad there is a specific bitmap converter already. Basically, it's already, there is no need to install any plugin. You can just import on PNG and basically turn it into a symbol. And yeah, basically Inkscape is very performative in this direction as well, and we can therefore implement interesting graphic into our PCB, which is nice for aesthetical reason as well for functional reasons. For example, we can implement instructions on it regarding how to put together the circuit or, well, whatever you guys want. Okay, so after that, of course, comes the assembly part, where basically we put together our circuit, our device, not only the circuit, and this is the final product that you can see. Basically the schematics and the circuit and the code are all open source. So if you go through my website, you can actually access whatever is necessary to produce this device. But let's go on. I also want to show you something else, which are not projects that I made on my own, like the DCM we just saw, but also art pieces that I worked for in the past years. The first one I'm going to show is called Lampiride, and it's an art piece made by Matteo Marangoni and Dieter van Doren, two Netherlands-based artists. And for them, I designed basically the casing for this installation. It's called Lampiride, and it's basically how the installation works is like this. There are about 100 small devices that can interact with each other. And of course, by interacting to each other, they generate very interesting sound patterns. Now I'm going to show you very briefly 2 videos of how the installation works. Okay, great. I'm not going to show the whole video because we're already short on time. So I'm going to show another video with the installation with like the whole setup together. No.
Nicolo, we did have a question.
Sure.
Sashi wants to know, could I use the first design to make a custom controller for a musical interactive video game installation?
I guess. Yeah, sure.
Cool. Cool.
Okay, nice. So basically, that's how they sound all together. Ooh. So what happened is that when the artists came to me, they arrived with this very rough prototype, and together we went through the process of turning this prototype into to the shapes we just saw. So how we did it? First of all, we started with some very, let's say, fast prototypes. So we made some sketches and we used this funnel and some plasticine to kind of understand the mass that these objects shall have in the end of the process. And then I moved back to Freecad. I moved to Freecad. This was the first time for the project. And yeah, we came up with this shape over here. And as you can see, as you saw, basically the device is made out of a 3D printed plastic shell with some ribs that somehow constitute the true shape of the object. The thing that you see on the right side, it's a render made of with Blender, which is another open source software that we don't see in details here, but it's cool to mention. So yeah, after we made the 3D models, we made a first prototype with 3D printing and laser cutting. This is the first prototype that we came up with, and yeah, it was nice in my opinion, but the artists were not happy with how smooth the shape was. So we moved back to 3D modeling, and we made the ribs a bit more organic. That's what the intention, and that's the final shape. And once we were happy with that, we actually went for mass production. As I said, we made like 100 of them, which is not fun. Like, don't do it. I mean, unless you have, we only had one 3D printer to make the whole set, and to make 100 pieces with the 3D printer, it's not really. I don't really recommend that unless you have a lot of time. So yeah, and this is basically a picture of the final installation. A cool thing that I didn't mention before is that these little creatures, because this is the basic metaphor of the installation, were handed to an audience. And the cool thing is that the audience goes around holding these little devices and interact with each other. So yeah, the installation was made in Den Haag in the Netherlands, I think. But this project has been shown very widely. It was also part of the Bauhaus 100th anniversary festival. Okay, so one more project I want to show is the noise board. The noise board, very simply, is a skateboard that sounds. So as you can see here, in that black shell, there are some sensors and a Wi-Fi antenna that transmit in real time the movements of the skateboard to a performer, so that it can turn the movements of the skateboard into a sound. I also have a little demo video for this that kind of sucks because we made it with our phone, but still. Okay, there we go. So now, okay. Yeah, so one thing that is cool to mention is that the sound design that was made by an artist called Giovanni Dinello was basically this project was funded by the city of Venice as part of a street art project. So the reason because we use this beat as a sound sample is because this was, in our opinion, a very street art thing. Well, the first thing we did to develop the skateboard was basically to find a place that was safe for our electronics components to be placed. And to do that, we used Freecad once again to make a mockup of how big basically the electronics were. And so we identified the lower part of the skateboard as a safe place where to put our circuits. It was actually very easy to find that because the skateboard we had was destroyed everywhere except for where we placed the device. So it was easy in a way. Okay, so after we did that, we came back once again to Freecad to basically shape our shell around a skateboard, because as you know, a skateboard is not completely flat, but it's a very particular shape. So we used some capabilities of Freecad to shape the shell in a efficient way. After that, we used a CNC milling machine to dig a hole in the skateboard, and we 3D printed another shell to enclose the circuit. Then we finally started to involve some electronics in it. The electronics we went for a microcontroller called SenseStage, and the wireless antenna are the XB. Maybe some of you might be familiar with it. One cool thing that perfectly with the presentation we are seeing now is that the SenseStage is developed on Freecad. So hypothetically, we didn't because we just didn't. But hypothetically, we could have imported the SenseStage KiCad file to our 3D modeling software to make a perfectly fitting shape. So, well, as you can see here, there is on the right side of the screen, there is a prototype of the first shell with fixing them. After that, we made a crash test. I also had a heart attack during the session. And what we did is basically we gave the skateboard to Alessandro, which was, let's say, the creator of the crew. We just said the worst, and he did. But fortunately, the device survived it. And so we went on. We basically optimized a little bit for the shells. We made a cap, a little lens to visualize the LEDs that are implemented in the controllers. And then we moved to another interesting part of the project, which was the aesthetical properties of the skateboard. So when we decided to turn a skateboard into a musical instrument, we also wanted that the way the instrument looked, well, the way the skateboard looked, would suggest that it was not an ordinary skateboard, but it was a musical skateboard. And so we started with the traditional Fs that you can find in traditional luthiery, so violins, cellos, etc. And we used Inkscape to basically generate this pattern. Basically, the F as they were, like identical to how you find them in cellos, we thought was a little bit not very interesting from a design point of view. Compared to a cello, we wanted to enrich this idea by adding this character. And this was possible through Inkscape. Just to mention again how performative can be Inkscape when you generate patterns and other graphical features that you might want to implement in your musical instrument. And then we imported the SVG file from Inkscape to Freecad and used Freecad to generate the code for our the result. We basically milled with Fs with our skateboards. Actually, we had a sponsorship for the skateboards, and they gave us these horrible skateboards with the pain. Just this tremendous maiden avocado graphic on it. Whoever had the idea of designing such a thing, we did. So we took some sandpaper, and of course we sand it off, and in the end we passed paint all over the skateboard to improve the strength of the board. The final product. Basically, yeah, that's it. I'm super happy with it. And after that, since the project was funded by the city of Venice, we organized some performances / workshops with the local population. Really fun because you must know that normally in Venice is forbidden. There is kind of a war between the police and the skaters that lived in Venice, but for once we had the permission. It was a great moment where the police that didn't know anything about this came to beat up these guys. And I came saying, no, you have a permission to get yeah, so we made these two performances in there, really fun. And this is basically the end of my presentation. Just one last thing I want to mention is that a special tab goes to STEAM. I don't know if you guys know what STEAM is. STEAM was an ancient research center all about electronic music, and that's where I started. And that's basically research that ever took place was thanks to STEAM. Now STEAM are fortunately, but I really feel like sharing my appreciation for what we
Excellent.
no longer. That's
great.
it. Thank you very much.
Wonderful. Thank you. Thank you. Sorry. Sorry.
No, don't worry. It's fine. I just sharing.
We'll figure out how to make it up. So I'm going to stop recording, and we'll get Eva will get ready. Two things for you though.